This Equipment World video is brought to you by Phillips 66 Lubricants, keeping the world running smoothly. Hey guys, what's going on? Welcome back into Equipment World. You're watching The Dirt, the video podcast that brings you interviews and discussion around the latest in construction equipment and what's going on in the construction industry in general. Today on The Dirt, we're joined by a very special guest, and that is Ray Gallant of Volvo Construction Equipment. Ray is a vice president at Volvo CE, and there's really no one better or more qualified than he to talk about the topic we're going to discuss today, and that is electrification efforts at Volvo CE. Now, I really credit Volvo with really being the first construction equipment OEM to take the first big leap or first big step when it comes to making a true commitment to producing electric machines. And that's because back in 2019, right in the run-up to introducing its first two electric machines at Bauma in Germany in 2019, they announced that not only were they going to do that, but they planned on replacing 10 models of their compact construction equipment lineup, 10 models that are diesel powered, replace them completely with machines that are battery powered. Now we're going to talk to Ray about those plans, the progress of those electrification efforts. We're also going to talk about the compact excavator and compact wheel loader that are already up for pre-order today. And we're going to talk about two concept electric excavators that the company has recently teased as well. Clearly there's a lot to cover, so let's get into it. Well, Ray, thank you so much for joining us today on The Dirt to talk about all of Volvo CE's electrification efforts. Welcome in.
Thanks. It's my pleasure to be here, Wayne. I'm looking forward to our interview.
Absolutely. Well, let's go ahead and get into it. Now we're eventually going to try to touch on all of Volvo CE's electrification efforts, but and there is a lot of talk about there, but I do want to start with really the most recent news that you guys have made in this area, and that is the 14-ton EX03 electric excavator concept that you guys recently posted a quick kind of concept video of. And my first kind of question is that, this obviously won't be the first electric Volvo machine. Volvo's got two compact electric machines that are kind of on the market already. They're in kind of pre-order here in North America. And then you had the work being done with these electric quarry tests that you guys were carrying out with Skanska with the HX02 hauler, the L01 loader, and the EX01 excavator. So there's a lot of work kind of already being done, and they were all interesting to kind of see those projects unfold. So I guess my question with this EX03 is, why introduce a mid-size wheeled excavator at this time as kind of your next electric concept? Why that machine type in particular for an electric machine?
So I think it's useful to kind of look at the concept machines and commercial machines as two separate streams of development. So we have the traditional yellow colored machines. They're the ones that have gone into production or are going into production as we speak. And then we have a line of development machines that are the lime green color that are more of a concept machine or a prototype that we want to get out there and test our concepts to make sure they work the way we think they're going to work, and also test to get customers' views in some situation. So what do the customers think of this idea? Is it useful to them? And that's a very important part of the development process, because quite often the customers will actually suggest applications and jobs that they could do with these machines that we had never even considered when we were developing them. So it's a good iterative learning process for both of us once we see the new features these technologies can bring to machines. So it's very different. Why the 14-ton? It's a very popular model out there, but I can tell you it's only one of a series of machines that are eventually going to be electrified. On the 14-ton, we happen to put in these few interesting features that we want to get some customer feedback on, so made it into a concept machine to get that feedback. But there could be other models that we'll talk about later on today and in the future that'll be coming out with an electrification slant to them.
Yeah, and while we're kind of talking about the importance of concept machines to Volvo, I did want to ask you about that. Just kind of this whole idea of taking a concept machine and showing it off to the public, and kind of having that public aspect to the machines as they're being developed. you really kind of answered this just a second ago, kind of talking about the importance of that, in development. But I guess my follow-up question to that is it just that just getting that customer feedback, is that the primary reason that you guys are kind of before the machine even really gets far along into development, kind of showing off some of these features? Is it really just kind of showing off those particular features that are highlighting that concept machine and getting that feedback? Is that the primary reason for the concept machines?
It can be a number of different reasons that we do that. One of the primary ones is to get customer feedback on a different feature, but it can also be to test out some things that we're going to do. You mentioned the electric site. So the electric site was made up of a number of different concept machines, but the difference was, how do we get them to work together? So that was the point of that. And you've also got a marketing aspect to it. So we want to be as transparent as we can with customers, with government, with companies, as to what is coming forward. Because if you look at the electrification journey, a big part of it is, do we have the infrastructure to actually charge and recharge these machines to make them useful on the job site? So we can, if we build a machine and we don't have a way to charge it, it's not going to be very useful to the industry. So we need to make sure that we're in concert with that. So part of the marketing journey that we're taking here is also being transparent as to what we can bring to the table as a company and what the industry can bring to the table, to make sure the infrastructure builds around the capabilities that we can deliver and everything goes in sync going forward.
Yeah, and you just mentioned the electric quarry testing you guys. I'd like to I'd like to hear a little bit more about that, because that's actually a little bit further back in the timeline than even some of these kind of individual concept machines. Now, you had concept machines, some of the lime green machines that you mentioned earlier, on those electric quarries. They were, as we've kind of progressed through the electrification journey, as you just called it, we've seen a little, and we've gotten closer and closer to like things that, are closer to reaching market. Let's put it that way. Obviously, the kind of scale has kind of gone down into the kind of compact equipment range. But on those electric site, I mean, because it is a quarry site, you get, like I said, you guys were working with Skanska on this stuff. There were larger machines, right? There was more of that kind of, here's the scale that we're aiming at for the future. Here's like a future quarry site. And you guys had really, like you said, a mix of stuff. I mean, you guys had haulers, and you had large excavators, and you had large wheel loaders out there. And there was some battery powered electric stuff like the HX01 hauler, which was not only battery powered, but it was also autonomous. It was basically a haul truck without a cab. So you had autonomous stuff, battery powered stuff, and then you also had an excavator out there that was electric and diesel, where a diesel engine could be powered on when needed, but then it was kind of tied into the grid for its electric power, which is also, like, especially for a mining site, a really interesting concept. Talk about that mix of machines, that mix of autonomous and manned machines, and kind of the importance of that electric quarry kind of testing, as I guess it's kind of like a foundation for what you guys are going to be doing here in the next few years of actually bringing some of these ideas to market.
That was the electric site was basically a proof of the validity of the concept of using these electric machines together in a real job site, replacing a real production rate with electric machines, and achieving the production rate at significantly lower cost, significantly lower CO2 emissions, of course, and also created a safer work site because you had less people down in the job area, less people walking around. It was basically a closed site, especially when the autonomous haulers were doing their work. But it really is a combination of a number of different technologies. And that, if you look at the way innovation is done now, it's never a single technology and invention that revolutionized everything. It's more an amalgamation of various technologies through a number of companies working together to bring these to bear. So when the communication technology through satellite and through cell was advanced enough that we could produce autonomous machines, that was an enabler for it. And then the battery electric in the small haulers enabled us to do a power source that had zero emissions, could be recharged in as part of the autonomous run and work basically without an operator. So that was a step forward. You just mentioned a dual power 70-ton excavator. So it has the advantage of a full diesel system, but it can run most of the time, if you're in a single location, off the grid electric draw. So it has the ability to run totally on electric and have zero emissions when it's working that way. We took a diesel crusher, converted it to electric drive as well. So it had no emissions. So the only emission producing part of the electric site was the hybrid loader, which has, of course, a much smaller engine driving an electric hybrid drivetrain. So it basically, we proved that we could reduce the CO2 emissions by about 98% on that site and take the cost of operation significantly down as well.
And I have a follow up for, just because, especially with that excavator being dual power, we on construction sites today, we already kind of have a very kind of similar thing in hybrid machines where it is technically dual power. You've got electric motors and you've got diesel engines. Everyone's aware of hybrid cars, and really the whole kind of hybrid idea is kind of like a first step toward electrification. How valid or I guess how long lasting will the idea of a hybrid machine or a dual power machine kind of be moving forward? Because obviously all the excitement or all of the kind of attention is really paid to going full electric, right? But with construction equipment, especially, it's really, especially when you consider that there's really kind of two kinds of hybrid or dual power, because you can't forget about hydraulics, especially with excavators. So you're going to have, even if you move to a battery machine, you'll have battery and hydraulics on some machines. Maybe in the future, you'll go all electric. And then you'll also kind of have, when it comes to the actual power source, being an engine or a battery or a mix of two. How valid long-term are these kind of hybrid solutions? Are they really just kind of a... are they kind of like, are we beyond that? I guess is what I'm asking. Or is there still kind of like a long runway left for hybrid and dual power solutions, even as we move into kind of full electrification? But before we get into that, I do want to take a quick second right here to tell you about the sponsor of this video, Phillips 66 Lubricants. Look, construction and mining are tough environments, not just on the people doing these jobs, but on the machines that they're using to get those jobs done. And when you depend on a machine to move massive amounts of dirt in as little time as possible and in extreme hot and cold conditions, these machines need the toughest lubricants possible to protect them. See, Phillips 66 has put thousands of hours into testing products like Gardol ECT, and with proven wear and corrosion protection, it's clear why 60% of the thousands of mining operations in the United States trust one brand to keep their equipment going, Phillips 66 Lubricants. So look, whatever you've got, graders, end loaders, dump trucks, Phillips 66 will protect it. You can even call the Phillips 66 technical hotline and talk to experts one-on-one about their product. Phillips 66 Lubricants, keeping the world running smoothly.
I think the best way to term this is a journey. So, where hybrids were one step along the journey, battery electrics are one step along the journey, but the limitations of those technologies can't do all the applications we need to do today. So there still is a place for diesels, and hopefully we continue doing things that'll clean diesels up and make them even more environmentally friendly. But there is still a place for diesel fuel, just because of the efficiency and the difficulty of bringing charging to all the job sites that we work on. So I view it very much as a development process, and I really think the battery electric is very suited to the small equipment and possibly into the mid-range, although you're getting into much higher horsepower or much higher voltage batteries. But when you get to some of the very heavy equipment pieces, you're going to see more hybrids and more other technologies come into play, like hydrogen fuel cells and things like that, that'll generate electricity and take care of the emissions problem, but do it through a different technology than battery storage.
Yeah, and I think the first thing that I want to kind of move on into in the EX03 itself, and this, I don't know, it really kind of applies to all of the, obviously battery electric stuff that you guys are working on. But I think my first question here, you mentioned kind of the challenge of going battery electric into some of the larger equipment, just for physics sake. I mean, you need a bigger battery for bigger machines, obviously. So how big of a challenge is that for these mid-sized machines? I mean, it's one thing to, and we've seen a lot of OEMs do this with kind of some of the retrofits on some of the compact equipment, and even kind of working with third parties. Now, you guys are not going that route. You guys are, Volvo is such. And I'll say, and just because of some of the announcements you guys have made kind of early on with regard to electrification, but obviously Volvo is a very kind of forward-thinking kind of company as a whole, not just the certain divisions around trucks and construction equipment and cars, but Volvo clearly has an eye on the future, and really more than a lot of companies has a real eye on design in particular, and integrating design across the company. So, like when it comes to these batteries and getting bigger and bigger and bigger, I clearly that's why we've seen more compact machines than not. But yeah, talk a little bit about the challenge of how big these batteries really need to be. I guess give us an idea of how much bigger a battery in a 14-ton wheeled excavator needs to be compared to something like you'd find on the smaller kind of compact excavator models.
So there's two kind of limitations here. There's the size of the battery is one thing, but what really is a concern is the weight of the battery as well. So especially when you get into something like a trucking application, the more weight you put into the truck, obviously the less payload you can carry. So there, our focus is on getting that battery as light as possible, but being able to recharge it very, very quickly, and then having the charging infrastructure to be able to do that. So you get into even things like inductive charging, where you'd be able to charge while you're traveling, would be technologies that we see in the future. If you look specifically at heavy equipment, of course, we can use the weight to our advantage in certain applications. So you can actually mount the batteries in the back and use them as a counterweight. So that helps a little bit. But really, it's a matter of not only replacing the diesel pack and doing everything the same as the diesel did, it's being smarter about how you do that. Because electric drives have very different drive characteristics than a diesel powertrain would, or a diesel hydraulic drive. So for instance, if you're at low RPM in a diesel, generally you don't have that high a torque, and you have to speed up your diesel to get a high torque. On electric drive, basically you have full torque as soon as the motor starts rotating. So using those characteristic differences and managing the power is where we're putting a lot of our focus. It would be, I won't say easy, but one way to do it would be to just take the diesel and replace it with the equivalent electric. But that's really not going to give us the duty cycles we want. It's not a very efficient way to do it. So we're trying to look ahead and work with new technologies that are going to give us not only better performance, but an increased energy efficiency. So we really use every volt we can get to the maximum advantage for the customer, and not have it wasted in heat or misalignment in your machine. Eventually you will get to the size where, to the point where the voltage is so high that it becomes an issue, or the weight is so much that it becomes an issue. And these other technologies offer us possibly other alternatives to there. So a combination of new technologies for powering, for alternate power, the new technologies for power management and better power management, as well as the battery electric drive. It's going to be a combination of all those factors going forward.
So I guess, like you said, like that, really the engineering problem is going to be on integration less than, because I think one of the things that we hear a lot, at least on the automotive side, and unfortunately that's kind of like our only kind of like point of reference right now, especially in the last few years. But like one of the things that you hear a lot on the automotive side, especially with Tesla, right, is that Tesla can't make enough batteries. And obviously every company is different. So, but I think that as we've kind of moved into this kind of like era of electrification on the engineering side, clearly making big batteries isn't easy, and making more powerful batteries that, as the weight goes up, as you said, as the weight goes up, that still kind of retain range and efficiency. So, so you see it more of a integration is the problem, and not necessarily availability or making more and bigger batteries. Is that correct? Or is that still a problem, just a lesser one?
Supply chain issues are a problem. I mean, we have to ramp up to be able to produce batteries in mass scale and be able to do it efficiently. The new technologies are a problem. We don't have all the suppliers in place yet to do that, but they're challenges that we will overcome. To me, the key to the success, and I hate to keep terming it as a problem, but the challenge is going to be how we integrate these and how we do it efficiently. That's going to be what drives us forward. Because like I said, it's not enough to just replace a diesel with an electric. We have to make it more efficient, more energy efficient, cleaner for the environment, safer for the customers, all those things, which we can do as side benefits of integrating these new technologies.
Okay, so let's go a little bit deeper into kind of the really kind of the development side of this battery technology. Now, like we've been talking about, the EX03 in particular is powered by a battery pack, and that battery system is going to be based on technology that's actually been previously used in the stuff that the Volvo trucks side of Volvo Group has been working on. So I think this question is really a two-parter. I'd like to hear your thoughts on what that work between these two sides of Volvo Group, Volvo Construction Equipment and Volvo Trucks, what that work between those two parts of the business looks like, kind of in terms of battery development right now, how difficult it is to kind of take a battery maybe initially kind of meant for a truck and kind of swapping that into an excavator. And then the second part of the question is really, Volvo Group actually recently announced a whole new business that's kind of centered around electrification efforts called Volvo Energy. And it at least kind of seems like that business is going to be kind of aimed at making some of this interdivision work a little bit easier and more integrated. So yeah, what does that kind of look like, leveraging, maybe work done on the truck side in the construction equipment, and maybe in the future vice versa?
Yeah, and I think that those are two related concepts. So we have the advantage in Volvo Group that we have, buses have been doing electric buses for almost 10 years now, and trucks have been working on this for a while, and construction equipment for a while. So we have all these different companies and different applications working towards the same thing. And if you think about a battery, at the end of the day, it's a set of materials that produce an output in volts and amps, basically, or watts. That's basically all it is. So the trick is, how do you take the right size battery and adapt your machine to work as efficiently as you can for the applications that customers have to do? So again, getting back to how do we make that efficient in a machine? How do we manage that power that we're given? And where Volvo Energy comes in is they can coordinate this work between the groups, and also bring on and look at cooperating with other partners. As I said in the beginning, these are not inventions that are done by some individual in his basement and spread out through the industry. These are conglomerations of companies that spend millions of dollars developing these technologies. So we want to secure partnerships with a number of different experts in their own core technologies and take those forward. And that's really the mandate for Volvo Energy, as I understand it, is they're going to help facilitate those partners, get the products to us to be able to build in as efficiently as we can to the machines. And also they're going to look at the long-term life cycle of these battery electric units and battery electric packs. So what do you do with them after the life of the machine is expired? How do you recycle them? How do you take care that we don't have a huge problem coming in the future with batteries that we can't dispose of properly or can't reuse in a second life? So Volvo Energy just kind of, and it was a very welcome initiative that just kind of brings all of that under one umbrella and one responsibility for the Volvo Group to take that forward.
How you're just kind of talking about these initiatives and kind of the interplay and kind of some of the internal development around this battery technology. Clearly, that's not able to happen everywhere. How much of an advantage do you feel like what you were just talking about with Volvo Energy, with the work that buses and trucks and construction equipment have already done on the battery side, and the ability just kind of to do a lot of this work internally, and then maybe for the supply chain side, then you look outside and establish those relationships. But obviously not every company, not all of your competitors have the kind of resources to develop internally. They're already, even when it comes to just like, hey, we need to put a battery in a machine, they're already like, hey, they're looking to outside help. How big of an advantage is that for you guys as we move into this kind of new era of machine power?
I think it's a huge advantage. Having the group together, having all those different applications that we can draw on, having the supply chains being formed within the Volvo Group is a big advantage to us going forward to integrate these technologies and bring them to market. Now, having said that, we're not naive that these technologies will very quickly spread, and suppliers have to be able to grow, and the battery technology and electrification technologies will spread to other industries, other companies. So it's not like we're trying to hide it. In fact, we're welcoming that transparency and that growth, because at the end of the day, that brings the prices down. It makes new technologies more available. It advances new technologies as well, because then the industry is working together on solving the same problems and making everything better. So I welcome that progress. But on the other hand, we have to acknowledge that it is a nice advantage for Volvo, and it's something that we worked hard to put ourselves in this position, to make sure that we were using all the leverage within the group to make sure that the technology advancements within the group were taken advantage of.
So kind of going back to the EX03 itself, the kind of the brief concept video that you guys shared on the EX03 really just kind of shows the excavator really roading, kind of coming off what looks like it had finished some work, and it's kind of coming off the sidewalk in an urban environment, kind of roading down the street a little bit. And as we mentioned above, earlier in the video, with the EX03 as a concept, it's planned on having just as much power as its diesel counterpart. You guys have kind of said, and a lot of OEMs have really kind of, as they've announced some of these concept machines or electric versions of existing machines, that's been one of the promises, is that the diesel version would be just as powerful. So you're not going to see a hit in performance, and really kind of the name of the game is going to be efficiency, lower emissions, lower noise. But what else is planned for this machine, or what do you guys kind of envision apart from some of kind of like the the big headline features, which we'll get into in a second? What from a development or engineering standpoint, in terms of performance, what is the hope to be able to deliver in this machine? And I know it's just a concept. This machine in particular won't be released on the market as it is. It's just a concept and a prototype machine. But what is the hope there on the performance side to be able to deliver?
Our first step, obviously, is the performance has to be equal or slightly better than a conventional diesel. So we don't want to be taking steps forward, if we could help it, that downgrade the performance the customers are expecting. So now, having said that, as the technology matures and is developed, we fully expect the performance will actually improve, and we'll be able to do things that conventional diesel machines cannot do. If you look in terms of the emissions and the noise, we're already at a point where these machines can go into areas and work where conventional diesel is very restricted or cannot work in those environments. So there's already that advantage coming forward. But from a pure performance part, and I'd rather talk about performance than power, because the amount of power a machine has does not necessarily equate to equal performance. So we're targeting equal performance, But if we can, we want to do that with much less power or energy consumption over time. So that's really the drive going forward. EX01 and the first electric machines that we've got out, basically, our statement is that they perform similar to the diesel machines. The components that drive them, if you look at the hydraulic pumps, the cylinders, things like that, they're basically equal to the conventional diesels. There may be a little bit of change in structure and stuff like that, but essentially those systems remain unchanged, and we concentrated on how we best take advantage of the electric drives that we have in these cases. The other big shift that you're going to see is the thinking is going to go away from how can we make an individual machine or application more efficient towards more how can we make the site more efficient. And there you get into technologies of machines communicating with each other, of scheduling, of planning, of queuing times, waiting times, all those aspects, which actually, if you look at a site operation, are far more inefficient than the actual 2 or 3% that we're going to be able to get out of a machine. If we can attack some of those site characteristics and make the overall site for the operator more efficient, or allow him to run a more efficient overall site, we have a much bigger gain on that aspect.
Yeah, and to that point, I mean, like, I think, it hasn't been a coincidence, right, that with as we've integrated more kind of electronics into cars and trucks and heavy equipment and stuff like that, that has also been kind of like a key, these electrical chassis have been really key in the automation, kind of moving some of that forward. And obviously those as we kind of move toward electric machines in cars and trucks, the automation starts to become more feasible and easily achieved. And then you're able to kind of start tuning a lot of stuff via software, be it power or automation or various other parts of the drivetrain. And so what it kind of sounds like too is that as each of these machines is able to kind of talk to one another, as power is more defined more by software than by hardware, you get into the point where you can start optimizing a construction job site, kind of almost like an assembly line in a factory, to the point where you're able to really have that fine-tuned kind of control over time, over costs, over efficiency. Does that sound right?
And again, that's the hope. That's where we're heading. And it's not for every job site. There are some job sites that there's too many variables that we're always going to have to do it on a reactionary basis. But there are many job sites and jobs that can be automated. And you're seeing the different levels of automation. I mean, we've been dealing with this for a long time. The return to dig functions on a loader are a simple form of automation, where it makes it very easy for the operator to get his bucket level and on the ground. Things like that we can build in and go to higher steps of automation, where the operator does not have to intervene as much and is more efficient, because he knows the bucket or the plow or the attachment is going exactly where he wants it and where he needs it to do his next operation. So all those things kind of come forward, but it's the combination of that I find very exciting, and was, again, going back to the electric site, that was kind of the proof of concept that came out of that. Is this really going to make a difference? And it turned out that it did.
Moving back to the EX03, I mean, kind of the headline feature of this, apart from the fact that it's electric and completely silent, which is definitely one of the cooler things about that concept video, is that you guys are trying to illustrate is just kind of how silently this thing kind of moves along the street. But the other kind of headline feature is that there's a giant what looks like, big screen TV on the back of it. Now there's probably a better way to put this, but to me, and I mentioned earlier, just kind of like how important design, especially in these concept machines and stuff, how important design is to Volvo. But it's a very Volvo-like feature to me on this concept machine. Why is that screen there? Why was this something that Volvo felt appropriate specifically for a wheeled excavator?
application, that screen could have been put in a number of different locations, but really a number of different machines. But really, when you think about what a wheeled excavator does, it's in around a municipal area, it's in tight quarters, there's always people around. When it's roading, there's cars right behind it, and it's a big machine driving in front of your car, so it cuts the visibility in back. So this was kind of a novel and different and unique way to say, okay, what if if you're driving behind, we showed you what was in front of the machine, so you know what the machine operator is seeing and what any obstacles or any problems that he may be seeing in front of him, and you could react accordingly. Another use for the screen is, what if we visually, instead of only a backup alarm, for instance, what if we visually gave a pedestrian a signal that the machine was going to back up? So a warning on that screen would pop up as soon as the machine goes into reverse, that everybody in back of it would see this screen that was saying the machine is backing up, use caution, or whatever the warning is going to be. What if we could send signals or text to the operators around, or the people around the site, via this screen? So there's a number of different uses of it, but again, it's a concept. So the purpose of it is to get people talking and thinking about the what if scenarios. How could this be useful on my job site, or would it be useful on my job site? And if it's not, if it proves out that it's not useful on a job site and has no great value going forward, then it won't be commercialized. If it proves out to have a value, then we're hoping to commercialize it and take it forward.
And, again, as we said earlier, no plans to bring something that looks exactly like this to market yet, just a concept, really just meant to kind of elicit conversation around the development of something similar to it. That being said, when could we expect something similar to the EX03? I guess either just let's just say a 14-ton wheeled excavator. When could we expect something like that to hit the market, kind of based on, I guess, the development timeline that you guys are currently in?
So there's a number of different initiatives going on throughout the product line, to bring a lot of models to market in the next few years. We see the acceleration of this electrification journey quite dramatically picking up now. You kind of had to get over a threshold of charging stations and acceptance of the technology, and we think we're crossing that threshold. So we think with the rise in automotive, with the rise in on-road electrification, now we see it spilling over to construction equipment. So we think there's going to be a lot of launches of machines from Volvo and from all other industry players in the next few years. So I would say by 2030, you will see quite a few of these machines out here. I'm not going to speculate on numbers yet, but it'll be significant within 10 years.
Well, I mean, based on the last few weeks, just how many different companies that we've seen, between, I can think of 3 right off the top of my head that had announcements just here in the last few weeks, the first few weeks of 21 here. And then, Con Expo, I feel like really was kind of the advent of electrification for the industry, really. There were just so many electric machines at that show. And again, just in prototype concept form. But kind of as a follow-up to that question, obviously, a lot has happened since 2019, but back in 2019, kind of in the run-up to the unveiling of the machines that are currently up for pre-order right now, the ECR 25 and the L25, the compact excavator and compact wheel loader, respectively, that you guys unveiled at bauma in Germany, and are up for pre-order now here in North America. One of the things that the company said was that they planned for kind of these electric compact excavators and wheel loaders to kind of completely replace their diesel counterparts in the lineup. Now, I know at the time the plan was by mid-2020 to kind of have 10 of those models on the market, stop diesel development, have those electric machines completely replace it. Obviously a lot happened last year. So but tell me a little bit about what, you've got the two machines that are up for pre-order now. Are the plans still for these electric machines to kind of replace the diesel counterparts completely? And kind of how much impact did what happened last year with the pandemic, how much of an impact did that kind of have on the electrification kind of roadmap that you guys envisioned with that initial announcement in 2019?
I think the coronavirus had an impact on everybody, and certainly had an impact on Volvo as well, in terms of, making it more difficult to keep moving at the pace we wanted to move. But a lot of those initiatives come about at the pace the market is willing to and ready to accept them, and the pace that the infrastructure is ready for it. So we're still intent on moving our development away from diesel technologies and combustion technologies in that light compact equipment towards battery electric. That is still happening. That's on track, shall I say. But the notion of replacing the diesels, or we're getting out of the diesel business, that's not quite accurate. We're phasing that out and reacting to the market and where the market goes with that in the future. So I think we'll see those models come on stream in compact line and in other ranges, like I said, very quickly. And I think you'll be surprised by 2030 how quickly they develop, just looking at the number of projects that we've got going and the attention that this is getting from all quarters.
And not long after the EX03 was kind of announced here recently, you guys actually also posted another electric excavator prototype to the YouTube page, and that is the EC230. Now, this isn't a concept machine like the EX03, and it's really just it's almost like a regular kind of machine that's going to be involved in a customer pilot. So it's more of a prototype than a concept. So why exactly the two different approaches? Why the concept wheeled excavator and then this EC230? And what exactly is that? This one's actually going to do some work, I guess, in South Korea with customers. Why the two approaches, and what's that customer pilot for the EC230 going to be like?
So the general idea is sometimes we would go from concept to concept and eventually to commercialization. So if you look at the autonomous hauler, we started out with an HX01, then it went to an HX02, which is the one we used on the loaders on the electric site, and then it eventually went to what we call a TA15, which is what we're now commercializing in autonomous sites and starting to put out there. So that same type of path goes with most equipment and a lot of development. Now, that doesn't mean that we won't take a model and directly go to a commercial variant. So through a prototype stage, then the commercial. And that's what you're seeing with the EC230. Now, Volvo is, of course, a global company. So one of the things when we develop a machine like that and it's in one market, then we have to go through and make sure we homologize it for all the different markets worldwide before we launch, to make sure it meets all the regulations worldwide. So that's the process that we'll be going through with the EC230 now going forward, and make sure it meets the requirements of the customers in the different markets as well. So, as we develop these machines, we'll do an evaluation as to which markets they're most suited for, and then make our decisions as to where we commercialize them and when. Going forward. Similar situation with the compact electric machines. They were launched first in Europe after Bauma, and then they're coming here to North America about a year later. And that a large part of that decision was based on the availability and the infrastructure build up in the different countries that we were looking at.
Now, this EC230 is a mid-size excavator, but which current diesel model is really most comparable to it? I assume it's the EC220E, because they're both kind of 22 metric ton machines. So why the different model number? And just kind of doing some research, that EC230, is that something that like a model number that's available elsewhere? Because here in North America, it seems like it's kind of like a throwback to the Ackerman days.
Yeah, not so much that. Our model numbers, of course, as you picked up, indicate the metric weight of the machine. So if you look at the 220E, it's pushing that 23 tons. So this is just a different model number, but it again reflects the weight of it. It's most closely based on the EC220, but you may see conventional diesel machines go to a different model number as their weight increases, as their performance specs change, and that's normal throughout the industry. So you see that progression as well. So there's nothing terribly significant in that different model number. What's significant is this an electric powered 22 ton class or 23 ton class machine.
And kind of one thing I wanted to touch on before we move on to the compact machines, because I feel like it's probably a little bit more appropriate for the larger machines. But, we were talking earlier about some of the dual power and the longevity of dual power and hybrid systems and, things like that. But one of the other kind of big things on these machines is Bobcat has actually been talking a little bit about this. They had an all electric machine at ConExpo where they had partnered with Moog, and Moog had kind of put in some electric actuators and motors in place of some of the hydraulics. I think obviously every OEM is probably looking at that kind of like all electric or fully electric kind of thing. What's your take on that? And especially with excavators, obviously one of the big things with hydraulics is going to be feel. It's going to be hydraulic attachments and kind of making sure that if somebody buys a new machine, they're not having to replace every attachment that they have. So there's lots of considerations, especially with excavators. But the idea of replacing hydraulics on construction equipment, where do you kind of land on that? What are some of the other considerations to take in mind? And do you think that is kind of like, that's the end goal, is to go fully electric? Or do you think there's going to be a place for hydraulics well into the future, even when battery electric machines become more common?
I think with the battery electric machines becoming more common, I think there's more opportunities to go fully electric machines. There's more chances to do that from a technology point of view. And there's also some applications where that is a benefit. So if you can go fully electric in certain situations, you don't have oils to contend with, you don't have any chance of spills, things like that. So there are some applications where that's a desired trait as well. Having said that, I don't see a wholesale switch in the near future in that direction. There's not enough advantage or enough drive, in my opinion, to make that wholesale switch. But do I think in the long-term future, it could very easily be that that's the direction we take.
Now, as we were talking about earlier, obviously there are two electric machines that are at least almost on the market here in North America. They've already been introduced to the European market, and that is the L25 compact wheeler and the ECR 25 compact excavator. Like we were saying earlier, these machines were first unveiled at bauma in 2019. They are up for pre-order now. When will these machines start being delivered here in North America, and what can customers expect from those machines once they arrive? What can they expect? And also, what have you heard from customers in Europe already about these machines in terms of what they're enjoying and how they're integrating into their workflows?
So the major feedback that we've gotten back from the customers in Europe that have used them, and the tests that we've done here in North America as well, is that the operators really like the quietness, the no emission, the feel of the machine. It's a different feeling on the machine when you don't have the noise, you don't have the vibration, you don't have the things that we're used to at a traditional diesel. Having said that, they also say that the power, the performance, everything is very, very good. So they're enjoying them. The feedback's been very good. We have to be careful with the duty cycles, of course. You've got a battery pack that's got a limited um, cycle on it, so you've got to make sure that we have infrastructure to charge it and that we can get that charged properly and at the right cycle. And that's going to take a little bit of adjustment for the operators and users as well to make sure they charge and have charging facilities adequately placed within their job sites. But more, it's everybody's very positive on it, but learning the new ways to work with it to take advantage of it is going to be the next step. So getting the feel for it, how hard to push the machines, how to use them to take advantage of that battery electric drive.
Yeah, I mean, and kind of following up what you just said there. I mean, like, especially with compact excavators. I mean, and with kind of how residential here in North America has been one of the one of the few things in a lot of areas that didn't get slowed down by the pandemic, in some places at least. But given kind of like the prevalence of compact excavators on residential sites, and given that it's kind of here in the last 5 years or so, its kind of rise in popularity, especially on sites where maybe a backhoe used to be used, and now the crew's bringing in a compact excavator and a CTL, or some of the smaller machines. I think it's tempting here at the advent of electrification to look at these smaller machines and be like, oh, well, they're starting here because, it's smaller, blah, 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 blah. But on the same token, I mean, like, these are big business. These are very important machines to any company that offers them. And obviously, like, if you're going to move one of these compact excavators onto a site, there's lots of things that are going to change, be it from feel, from workflow. What does that look like? You mentioned the charging infrastructure. What does that look like with, let's just, I guess narrow it down to just the, I guess for both machines really, but I'm kind of thinking like on a residential or a job site with that ECR 25. What does that look like in terms of like having a place for that machine on the job site that can charge? I mean, is it just a standard extension cord, or like what needs to happen on a job site to charge one of these things?
So again, depending on how you need to use the machine or how you want to use the machine. So all our machines, like automotive, they come with basically a plug. You can plug them into 110, but then you're going to be waiting a long time for the battery charge off 110, 120 volt. You can plug them into a household 240, and that basically gets you an overnight charge sufficient for next day's work. And then we also have a line of fast chargers, which are usually DC direct chargers that will allow you to quick charge a machine. So again, if you look at in the future, as these fast chargers become more available and that technology matures, we expect it'll be a lot more prevalent that you shut your machine down while you're having lunch, plug it in, get a quick charge, and that gives you all the power you need to work the rest of the day. And that allows us to keep the battery packs smaller and keep your charge time to a minimum. So that's kind of the drive going forward. But as I said, it's a change in how you do your job that's going to be gradual. We're going to have to work with the customers through and see what works for them as well.
Now, you mentioned the quick charging kind of. Is that going to be, I guess, when these machines kind of launch here in North America, is that quick charging capability going to be available immediately?
Yes, it'll be available upon launch. Again, the infrastructure is not there yet, but we will be selling units that'll allow you to quick charge our machines. And then as the infrastructure grows, we expect to be able to plug into more and more chargers and to be able to charge wherever you are.
Now, how much faster is that quick charge over the household 240?
Over the household 240, it's about 8 or 9 times faster, something like that. Again, depending on the power you draw through it and depending on how you configure it. But in these two particular machines, it's about 8 or 9 times the rate that you're going to get with the 240 plug.
Now, the looking for a second at the ECR 25 specifically, that machine's, they're both of these machines are battery powered. The battery pack sending on the excavator, though, the battery pack sending power to a single electric drive motor that powers the hydraulics of the machine. So, how would you characterize how this machine compares in performance to its diesel counterpart, the ECR 25D? That's powered by a 20.9 horsepower diesel engine. Obviously, we had talked about earlier that you should be able to expect similar performance, or really what's the point of this? So I guess really more my question is, you mentioned it's going to take operators a while to kind of get used to maybe the feel. Is it more of a feel, or is it more of a kind of working with, I guess, like how different is this machine going to be in the hands of an operator who's used to a diesel machine? Just as capable, maybe even more capable? Yeah, give us an idea of what that's like.
For an operator, and what we're hearing on these first few machines is, as he's operating it, it's exactly the same. The difference is he has no noise, no vibration, no emissions. But the feel for when he's digging a hole, or when he's pushing, or when he's loading, the feel is exactly the same as he's used to. And that was by design. We want to make him familiar with it so he can operate as efficiently as possible. As we go forward, of course, we expect to be able to get even more out of the electric drives, but it'll probably be more in terms of longer range, longer duty cycles, more automation, things like that we'll be able to build in now that we have them connected, now that we have them digitized, now that we have them electrified.
And I haven't seen any kind of, on the excavator, I haven't seen any kind of like lift charts or dig depth specs, or are all of those going to be identical or nearly identical as what you would find on that EC R25D? Or
yes, they're built off the same chassis as the 25D. So the boom, arm, the specs are exactly the same. The hydraulics, most of it is the same. So you're not going to see a difference that way. It's not like you have to get used to a new boom configuration or anything else. The loader does have a different lift unit, but basically the performance will be very, very similar.
Now on the ECR 25, you guys are claiming an 8-hour kind of work cycle per charge of the battery. Now, give us an idea of that 8 hours at charge. Is that at a full load, or is that kind of like an average across kind of different, light and heavy types of work? Is it at just light loads you get that 8 hours? Give us an idea of how you can achieve that 8 hours per charge.
That really, the best way to say it is that's an average duty cycle for 8 hours. So if you used it in its absolute worst power condition for 8 hours, the battery's not going to last that. So, but for 95% of the jobs that are out there, this would last the 8-hour day. He'd be able to do the job. There are a lot of factors that come into that. So that is a rating that we have to be a little bit careful with, because of course, even temperature has an effect on the battery discharge and the efficiency of the battery. So we have to learn about that as we go forward. But the design life is for an average duty cycle to be able to work 8 hours comfortably.
And then, in terms of the maintenance on this excavator, what does maintenance look like on an electric ECR 25?
Obviously, you have a lot less moving parts, and the parts like the electric motors, the battery packs, things like that, they don't require lubrication, they don't require oil change, they don't require filters. So a lot of that maintenance draw goes away. So we're expecting the combination of those two, and what we're seeing in early indications is that these machines will require much less maintenance and also have less or breakdown and repair cycles than a conventional diesel machine, just because of the fact that you have less moving and less wear parts.
Now, unlike the excavator, the L25 is actually going to have, they're both going to have battery packs, obviously, but the L25 will have 2 electric motors as opposed to the excavator's 1. Now, on the loader, that's because one of the motors is for the drivetrain, one is for powering the hydraulics. Now, it as well is supposed to have an 8-hour work cycle per charge. So, again, it's kind of a similar question to the excavator. Is that, again, 8 hours average, or is there any kind of difference in what you can expect in terms of that work cycle per charge on the loader compared to the excavator?
Again, it's a similar type of rating. So we're designing for the average user to have no worries to work his 8-hour day. But if you absolutely put it into the toughest conditions for an 8-hour day, you're probably going to run out. Your battery is quite low.
Now, if I guess as a follow up to that, what would you say if you were going to go full load? What would you drop to? About 4 hours, 6 hours? I mean, is it a more significant drop than that?
No, we would expect even under the toughest conditions, we would be able to get half the day done. So at least to get you to noon hour to lunch break to be able to recharge the machine. And again, that's part of what we're looking at in these machines. If you look at the electric site, the autonomous haulers, they actually did one dump cycle between each charge. So there's only 8 minutes to a dump cycle, and 1 minute of that for each hauler was spent charging. And that's the way we see these going forward. So you'll have a lot of work periods, but a lot of short charge intervals in the future going forward on these work sites. So you'll be able to, work a couple hours in the morning, take a break, plug the machine in, quick charge it, and you're back up to full power by the time you get off break.
Now, the diesel counterpart to the L25 is the L25H. That's powered by a 64.4 horsepower engine. Kind of a similar question to the excavator. I mean, is this going to be identical in terms of those spec sheets, in terms of all the numbers that the L25H currently hits, and for operators, moving things around with one of these loaders? I mean, can they expect similar, or identical performance to what they're already seeing on the L25H, just like that ECR 25 and its diesel counterpart?
So the HS, actually, the high-speed version of the loader is the 64 horsepower. The standard L25 is 48 horsepower. The electric will be matched to the 48 horsepower performance. One of the characteristics, if you look at the power draw, the hardest use cycle for a loader probably is high speed. That's where you really need a lot of power. So in the electric machines, we've restricted that to basically a standard speed machine. We don't have a high speed version of that yet. So you are going to see that one performance difference. If you were to road the electric loader for long periods of time, or had a long distance to travel, that's probably not an ideal application for an electric machine.
Yeah. So and everything else, though, in terms of lifting capability and
right, everything else in terms of lift, in terms of reach, in terms of feel is going to be exactly the same, and it's very, very similar to a standard machine. We just don't have a high speed variant in the electrics yet.
Is there anything else about and I assume we'll have more information on both of these machines as we kind of get closer to the actual launch here in North America, but is there anything else in particular about the L25 and the ECR 25, the electric machines that as these pre-orders are now open here in North America, is there anything in particular that you feel like for folks here who are looking at a machine of this size, whether it be for agriculture applications or any application you might use a compact excavator on, be it home site or roadside or otherwise? What are some of the things what's some of the things in particular about these machines that you want prospective buyers out there to know if they're considering kind of getting in here on this bleeding edge of electrification?
I think it is a different technology, so there are some changes when you start talking electrification and charging systems and charging intervals and all that. It is a different technology. I think one of the exciting things that will come out of this is there's going to be new applications that we never considered diesel machines to be able to do, that these electric machines are going to be able to satisfy or be adopted to satisfy. So that's one of the things I would say to anybody considering this is don't limit yourself to thinking of replacing only a diesel. Think about all the other applications that this machine might be suitable for, and only uniquely suitable for that matter. So if you need to work in a quiet environment, this machine can do it, whereas a diesel machine cannot necessarily work in that environment, or if you have emissions concerns or things like that. So I think the uptake of these machines for a prospective buyer, I'd say really carefully consider what these unique features can bring to your work site and can bring to your jobs and can allow you to do that you couldn't do with a conventional diesel machine. To me, this is a very exciting time because it is moving these different technologies forward and enabling the different technologies to really come to fruition in our industry and to make us much more efficient and productive in what we're trying to do. So I think it's a very exciting time. It's a great time to be working on this.
Absolutely. All right. Well, Ray, that is all the time that we've got on this episode of The Dirt. Thank you again so much for joining us today. This has been a real pleasure to hear kind of what's kind of going on inside Volvo in respect to electrification. Like you said, it's a real exciting time in construction, in the construction equipment industry in general, to kind of be looking at all the changes that are coming down the pike. So again, thank you so much for your time, for spending some time with us today talking about what is in store. Thank you again, and be well.
Thank you, Wayne.
All right, guys, that's going to wrap up this episode of The Dirt. Thank you so much for joining us. And thank you again to Ray Gallant of Volvo CE for joining us today to talk about the company's electrification plans. But we want to know what you guys think as well. Let us know what you think of Volvo's electrification efforts. Let us know what you think about electric machines in general and what you would like to see out of an electric machine that's going to prove to you that it's ready for prime time work in the field. And if you like this video and found the information in it useful in any kind of way, but especially in your next machine purchase or rental, do us a favor and hit that like button below. It really helps the channel out. And if you want more coverage, more videos of construction equipment, head on over to our website at equipmentworld.com. And while you're there, subscribe to our daily newsletter. And if you haven't already, subscribe right here on YouTube. Hit that subscribe button below. And be sure to hit the bell, turn on notifications so you're getting up-to-the-minute alerts whenever we drop a new video. All right, guys, that's going to wrap this one up. Again, thank you so much for watching. We always appreciate the time, and we'll see you in the next one.